Yes, my dear kids, let us use chat box. Let us use chat box to communicate me. Am I audible? Please use chat box to communicate me. Am I audible, my dear kids? This is only today we shall have class on YouTube. From next class we shall go back to Zoom or direct class whatsoever. Okay, come on. I am waiting for your chat on the chat box. Amrita, yes sir. Amrita Sharan, Aditya Sharan, yes. Arun Kumar, good evening. Yes. Priyankavatini, yes. Priyanka Revati, yes. Yes, okay. Praveen Krishna, yes. Excellent, excellent. Yes, Kanna, yes. So, that's fine. So, let me give first the brush up of complete CBSE level. Yes, Kanna, good evening everyone. So, let me first do the brush up of CBSE level and then we will go for IIT level. Shall we begin? Yes. Electrostatics. What do you mean by electrostatics? Charges at rest, not mobilizing charges. Charges are static at rest, velocity 0. What do you mean by charge first of all? What do you mean by charge first of all? Define charge to begin with. Let us define charge. Please take your notebook, rough notebook, not regular physics notebook, rough notebook and pen. Just scribble, write whatever we discuss here. This will give you complete revision, feel of complete revision of this electrostatics, right? Okay. Charge. What is charge? It is a fundamental basic entity in the universe associated with mass, which interacts with similar entity. Once again, what is charge? For example, electron, for example, proton. What do you mean by charge? They are always embedded, associated with mass. Okay. So, charge is a basic entity, okay, fundamental entity associated with mass, which interacts with similar entity, It manifests in nature only in two forms. Popularly, historically, we call it as positive and negative. Historically, we call it as positive and negative. So, according to us, proton has got positive charge and electron has got negative charge. This is a historical reason, there is no algebraic reason for this. Okay. This is regarding what is charge. Then comes how to charge a body. What are the properties of charge? Charge is quantized, means the minimum charge on the given body. Suppose it's a body. It has got charge in it, say charge. What's the minimum possible charge? The minimum possible charge is 1.6 into 10 power minus 19 coulomb plus or minus. This is the minimum possible charge. You can't have less than this. So, this is charge is quantized and charge is conserved. Like charges repel each other and like charges attract each other. That is what is interaction, all those. Okay. How to charge a body? In our class, we have discussed 3 methods of charging a body. What are they? Come on. What are they? One is charging by conduction. Number 1, conduction. Number 2, induction. Number 3, friction. For charging a body, a given body can be charged by 3 methods: conduction, induction and friction. I am not going to explain much about it. Conduction is sharing of charge, induction is inducing the charge by earthing the other side of the conductor, and the last one is friction. Mostly we are using these 2 methods, we do not use much of this method. Induction and last one is friction. When 2 bodies rub against each other, the electrons get transferred from one body into another body. In simple language, in one body if the electrons are loosely bound, in another body electrons are strongly bound. The electron go from a body in which it is loosely bound to the body which is strongly bound. Yes. Sriram, lot of good evenings. Yes, Kanna, all of you, good evening. Yes. So this is, today I am going fast, you know, we have spent more than 1 month in completing this, but today I want to give complete brush up just in maybe 1.5 hours or 1 hour and 45 minutes. So, yes. So from next class it will be perfectly either Zoom, yes, mostly it is Zoom, it is going to be Zoom, right. Now what do you mean by interaction between the charges? You want to take a point charge, you know what is point charge? If the physical dimension of the charge is highly negligible compared to the space around it, we take the charge as a point charge. The force of attraction or repulsion between the 2 point charges is given by Coulomb's law. What is Coulomb's law? If these are the 2 charges, suppose, these are the 2 charges, suppose, say Q1, say Q2, right, then this is force on 2 applied by 1, this is force on 1 applied by 2, right, force on 1 applied by 2, yes. What is the force? Modulus, Q1 modulus, Q2 modulus, 4 pi epsilon 0 r square, where r is the distance between the 2 charges, where r is the distance between the 2 charges. Then if you want it in vector format, what do you need in vector format? You want to exactly explain what is the direction of this. If you want to find direction of this, first you have to fix a coordinate system like this. Yes, it is a coordinate system now, x axis, y axis. So your Q1 has got r1 vector, position vector, what you learned in 11th standard. Your Q2 has got r2 vector, position vector. Then this maybe we preferably call it as r12 vector, you can call the other way around also, not a problem. This is r21 vector, right. Now what is the formula for this? Come on. F21 vector is simply given by Q1, Q2, 4 pi epsilon 0 r square, come on, r2 vector minus r1 vector, provided what you are discussing is a repulsive force. Provided what you are discussing is a repulsive force. If it is a repulsive force, then this is the direction of force, right. So very easily you can remember 2 minus 1, force on 2 applied by 1. We come to the other side, yes, force on 1 applied by 2, come on, force on 1 applied by 2. The story is going to be same, Q1 modulus, Q2 modulus, 4 pi epsilon 0 or modulus Q, I have done mistake here, Q, yes, I am using different color, okay. Then r1 vector minus r2 vector. Please check it. This is force on 1 applied by 2. This is force on 2 applied by 1. Please check it. This vector format, I am not going in detail how we have got this. That and all we will take up from next class. I mean from tomorrow, we will take up all those things. Okay. Today I am going a bit fast. Just I want to give a recap because nearly last 1 week I could not meet you. Summer. So just I want to give recap of entire lesson. Please take notebook, pen, scribble it, write it on your rough notebook. It's amounting to complete revision of the topic, right? Shall I clear? Yes. Iskana, am I audible? Are you copying it on notebook? Please let me know on the chat box. Raghavan, can you tell me? Sriram? Narayan Srinivasan, come on, Kanna. Please let me know on the chat box, please. So, Sriram wants me to start chapter 3, means current electricity. Of course, from next class we shall do that. We need some warm up after yes, so many yes. Excellent, Kanna, excellent, excellent, Kanna. I'll go ahead. So, while calculating this force on one charge due to the other charge, always we use some vector technique for easiness. For example, suppose it's a square, you have charge q here, you have charge q here, it's giving you force here on the third charge here q3, you get a force F here, you get another force here F. These two charges being equal, you will get the same force, equal force I mean, but in different direction 90 degree. Now the resultant is simply root 2 times F, simply root 2 times F. Now I have been doing one, I am continuing doing only CBSE level, I am not taking it to IIT level. We will take up IIT level separately, right. I do not want to mess with the students who are preparing for CBSE, unnecessarily I am telling all the IIT stuff and confuse, I do not want. Okay. Suppose it is a triangle by chance, where here is a force F acting, here is a force F acting. Clearly, if it is an equilateral triangle by chance, this angle is 60 degree. If at all two forces are equal, then your resultant is root 3 times F, root 3 times F. Right now, like that, the geometrical technique you must know, something about geometrical technique you must know. Then comes, I am just referring what are the topics, then comes continuous charge distribution. If it is a line charge, it is a line which is completely charged, then charge per unit length is called lambda, charge per unit length, particular charge by particular length, unit coulomb meter per minus 1, right, lambda, line charge density or linear charge density. Then comes aerial charge density or surface charge density. If it is a thin sheet surface which is completely charged, thin sheet surface which is completely charged, right. Then the surface charge density sigma is given by charge by area given by dq by dA, surface charge density, total charge of the surface by total area, or particular charge by particular. This technique we can use only if and only if the charge is spread throughout the area equally, I mean uniform distribution of charge throughout the area. Similarly, total charge by total length can be used if and only if the given charge is distributed uniformly over the linear body, long body, okay, like a thin wire, then only we can use it. Then comes volume charge density. If you have a three-dimensional body, like this, right, cube or sphere, solid body, where the charge is completely filled even inside the volume of the body, which is not possible in the case of metals. This is possible only in the case of non-metals, I mean insulators, they are only possible. Then the volume charge density rho is given by total charge by total volume or particular charge by particular volume, provided it is uniformly distributed. It is called volume charge density. Then comes lines of force, or electric field lines, lines of force or electric field lines. What do you mean by electric field line? Electric field line is a curve, tangent drawn to it at any point gives the direction of electric field at that point. So for example, this is the electric field line I climb. Then if you draw a tangent here, this is the direction of electric field. If you draw a tangent here, this is the direction of electric field. Once again, what do you mean by electric lines of force or electric field lines? The electric field lines are the imaginary curves, tangent drawn to it at any point gives the direction of electric field at that point, right? Good. This is electric field lines. What are the various properties of electric field lines? Electric field lines originate from positive charge and terminate at negative charge because it is always measured as force per unit charge on electric field is measured as, electric field by itself measured as force per unit charge provided limit q naught tending to 0 is called electric field. So clearly electric field is measured as force per unit charge on an infinitesimally small positive test charge. Therefore, on an electric field line suppose, you leave a test charge here, say for by chance, you leave a test charge here q naught, very small positive test charge. Definitely it experiences force in this direction, which is same as the direction of electric field, provided you leave a test positive test charge, provided you leave a positive test charge. Clear now? Clear kanna? Yes. Yaro yes podunga. Harini, come on kanna. Yes, I think I got a yes. properties of electric field lines over. Now I am strictly going with CBSE. I will definitely come back to IIT at the end, right. Now go to, what is that? Electric dipole. Shall we go for electric dipole? What do you mean by electric dipole? If equal and opposite charges are separated by a very small, negligibly small, very small distance, then it's called electric dipole. So if a positive charge and a negative charge and positive charge separated by a very small distance, 2D vector measured from negative to positive, then electric dipole moment P vector is given by Q into 2D vector. I have been telling in my class many times, electric dipole, all your chemical compounds, I mean molecules, are readily electric dipoles, yes, electric dipole, where electric dipole moment is given by charge multiplied with the distance, therefore its unit is coulomb meter. Coulomb meter is the unit of electric dipole moment, right, electric dipole moment. And which then we want to know electric field due to electric dipole. Come on, suppose it's an electric dipole, plus Q minus Q, it has got electric dipole moment P vector equal to Q into 2D vector, okay, electric dipole moment. Then here is electric field, E vector is given by 2P divided by 4 pi epsilon 0 r cube. I am talking only about the modulus value on the axis. I am not giving direction to this. Similarly, here is the electric field on the equatorial line. This is the opposite to this. Actually, this electric field is in this direction. So electric field on the equatorial line, of course, modulus term given by 2p divided by 4 pi epsilon 0 r cube. This 2 I should remove because electric field on the axis is twice that on equatorial line for the given distance. So provided this distance is r, this distance is also r. For the given distance r, electric field on the axis is double that on equatorial line. If you choose any point here, any point at the distance r making an angle theta, what is the electric field at that point? Of course, it is not exactly in CBSE, but however, electric field at this point is simply given by P divided by 4 pi epsilon 0 r cube square root of 1 plus 3 cos square theta. Substitute theta is equal to 0. Substitute theta is equal to 0, you will get this. Substitute theta is equal to 90, you will get this, because this is 90 degree, you will get this result, right. So this is a common electric field general formula for electric field at any point in the given plane, anywhere in the plane of the given plane, so maybe XY plane most of the time use, right, or cube. Now the point is that what is the direction of electric field at this point? What is the direction of electric field at this point? Let me explain you the direction of electric field. Look carefully. This positive charge, negative charge. Let me explain you the direction of electric field. Paklama, direction of electric field paklama. Gavanikal. Yes. Now electric field line go like this. Electric field lines go like this. Away from positive, entering into negative. Right. Away from positive, entering into negative. Away from positive, entering into negative. These are the direction of electric field lines due to a dipole pattern, right. It will go like this. Yes, these are the electric field lines. Arrow mark goes like this. Why I am drawing this? Now you can understand. At my point here, look at. This is the electric field. This is the direction of electric field. Tangent. This is the direction of electric field at that point. This is the formula I should use. By chance, I use theta, this theta to be, say 60 degree for example. 60 degree for example, you substitute cos 60, you will get the answer. 3 by 4, 1 plus 3 by 4, you will get under root, right. The point is that, what is the direction of this electric field? What is the direction of this electric field? Let us say that this makes an angle phi with x axis. Then one can prove that tan phi is equal to 1 by 2 tan theta, sorry, 1 by 2 tan theta. It is always true. Tan phi is given by 1 by 2 tan theta, right? Tan phi is equal to 1 by 2 tan theta. It can be always proved. This is the resultant force. How do you get resultant electric field? Resultant electric field is due to x-axis plus y-axis, all those, right? Go to next page. Of course, this is not in CBSE level. This is purely for IIT level. Good. Now I think it's right time I have to take you for electric flux. I think I can go fast and complete this CBSE level in another 20-25 minutes, and then later I will take up all the IIT stuff. Okay. Electric flux. What is electric flux? Electric flux linked with the given surface is simply given with a scalar quantity. Electric flux is a scalar quantity. Electric flux is simply given by E vector dot ds vector. It is a dot product of electric field and area vector. It is a dot product of electric field and area vector associated with the electric field. So, if you want to use this, you should ensure that for this entire, suppose this is ds, suppose. It's got vector quantity, suppose, in a particular direction. You know very well how to calculate area vector. Area vector is always perpendicular, outward normal to the given surface is called area vector. Outward normal to the given surface is called area vector. Right. Now, this is E vector, then this is theta, so E dot ds, you get. Suppose theta is equal to 0, you get maximum flux. If theta is equal to 90, you get 0 flux, all those things. Right, Kana, electric flux is simply E dot ds. No, sir, E is a variable, what to do? For this to be true, E vector must be constant. In the sense, in physics we call it as uniform. Constant we call it as uniform, right? But if it is variable, what to do? So simple. Electric flux is simply given by integration of E vector dot ds vector, provided it is a surface integral. Because you are talking about surface, it's a surface integral. So you have to take surface integral, not the linear integration, like integration of x square into dx is given by x cube by 3, not that integration. You have to integrate over the surface area. Right? If you want to integrate over a closed surface area, put one circle here. If you want to integrate over a closed surface area, then you put in circle there. If it is an open surface, no wonder you can have open surface even. For example, if you run integration over this surface, electric flux linked with this surface, suppose, it's an open surface, it's not a closed surface. You can go ahead with that, right? Good. Now, applications of this, well-known applications. The first one is electric field due to infinite thin wire, minus infinity to plus infinity, provided it's a uniformly charged wire. What is the charge density? Lambda. Charge density is lambda. Then the electric field is given by lambda divided by, 2 pi epsilon 0 r. 2 pi epsilon 0 r. So this is electric field. This is r vector. This point is the electric field, and this r vector r. From here, yes, you can put r cap also if you want, because electric field is in the direction of r cap, which is same as r direction, provided your wire is thin, uniform and infinity. Having a line charge density lambda. Number 2, thin sheet. Second application is thin sheet. Thin sheet. Sriram wants a playlist of the entire electrostatics. Sure, already I guess shared many times. I'll share it even today. Sure. Harini, yes. Anything, any doubt? Aditya, Sriram, clear, very good, excellent. Can I please communicate me on chat box, please? Do communicate me on chat box, please. Thin sheet. It's a thin sheet, as I've been always telling. Thin sheet means it is unimaginably thin sheet, not like a white paper. It's ultra thin, and you have to go to atomic layer thin. So which may not practically possible, but for gold la mattum avlo melisa panna mudiyum. Gold sheet mattum நம்மளோட physics definition படி thin sheet create பண்ண முடியும் because it's highly ductile. Yes. Now when you consider Gaussian surface like this, when you consider Gaussian surface cylindrical, perpendicular, then finally you will get that electric field is given by, come on, sigma by 2 epsilon naught, provided it's a thin sheet. Provided it's a thin sheet. No sir, I have thick plate, what to do? So this is your thick plate. This is your thick plate, okay, a metal plate suppose. Here is the charge, sigma. Here is the charge, sigma. Then here the electric field is given by, again the electric field, two electric field. One electric field is given by sigma by 2 epsilon naught. Another electric field is given by again sigma by 2 epsilon naught. Right? Together it is sigma by epsilon naught. Together it is sigma by epsilon naught. Therefore, instead of thin sheet, if you have a thick sheet, electric field near the thick sheet is given by sigma by epsilon naught. Not only for this, for any general body, suppose you have a irregular shape like this, which is completely charged, right? It's completely charged. Electric field at this point is like electric field. What's the value of electric field at this point? Electric field at this point is given by sigma by epsilon naught. Okay? So electric field near the surface of any body charge, any charged body, preferably metal, any charged body, preferably metal, is simply given by sigma by epsilon naught, whatsoever the shape, whatsoever the shape. Yes. Satvika, no doubt, very good Kana. Priyanka Revati, sir, could you please show the first application of electric flux? Yes, first application of electric flux is this thin wire, thin infinite wire, sigma by epsilon naught into R cap. Yes. Yes. Now we have to go to solid sphere, a spherical body, sphere, conductor. By claiming its conductor, here the electric field is 0. Yes. What is electric field just outside here? Here electric field is given by R, Q divided by 4 pi epsilon 0 R square for the case where R is greater than R, where R is the radius of the sphere, R is the radius of the sphere, right. Then comes inside, already I told you it is 0, just on the surface, just electric field on the surface is given by, come on, Q divided by 4 pi epsilon 0 R square, where R turns out to be capital R. Inside electric field is 0 for any point R less than capital R. So this is mean for a conductor. So in the conducting sphere does not hold any charge inside the volume of the body. Every charge that you give stays only outside the body, and I mean just on the surface. Therefore, on the surface you will get maximum electric field. Outside, of course, it behaves like a point charge and the electric field decreases. When you go inside, the electric field is 0. Right, Kanam? Yes. Who is asking this? Madhushri. Madhushri is asking whether the I'll go back. Previous page. This is what she is asking. Very good, Kana. Madhushri is asking whether the sigma by epsilon naught is mean for only one side or both sides. Of course, here also you will get sigma by 2 epsilon naught. Here is sigma by 2 epsilon naught. again sigma by epsilon naught, because this surface contributes here, even this surface contributes here. So, you will get 2. Similarly, this surface contributes the first one, sigma by 2 epsilon naught, again this surface contributes the second one. So, you will get. So, in the simple language, in the case of a thick sheet, what we call a simply sheet, you get electric field sigma by epsilon naught on both sides, sigma by epsilon naught on both sides of the sheet, Very good, Kana? Madhushri has this doubt. Very good. I take you back. Yes. So, this is a metal conductor. A sphere, as per our CBSE syllabus, we have spherical conductor where the electric field inside is 0, electric field outside is given by this. Suppose it is a non-conductor and the charge is uniformly distributed. Of course, this is not in CBSE, but I want to complete that. So, it is a sphere, it is a non-conductor, I mean dielectric. So, dielectric sphere, yes. Right, dielectric sphere. Or now, when you take any point here, the electric field is same. Suppose the total charge is Q, then electric field on the surface is simply given by Q divided by 4 pi epsilon 0 R square. What we have seen in the previous case, exactly same. Now, you go somewhere outside. Right? Shall you go somewhere outside? Yes, Ingapoli. Here, where R greater than capital R, outside, E outside. Again the story is same, Q divided by 4 pi epsilon 0 R square. The question comes only when you come inside. So, when you come somewhere inside, Paklama, yes. When you come inside here, at the distance say x, what is electric field at this point? Electric field inside is given by Q divided by 4 pi epsilon 0 yes, Ex divided by this distance x is proportional to x, is supposed to be proportional to x, right, x divided by r cube, right. Electric field increases or electric field decreases. When x becomes 0, electric field becomes 0. So, at the midpoint here, electric field at the center equal to 0 because it does not enclose any charge. Suppose you go to surface, you have to substitute x equal to r. See, this x increasing at the surface, x equal to r. Substitute x equal to r, you will come back to this result. So, this is the electric field inside charged, uniformly charged, non-conducting sphere. Uniformly charged, look at here, dielectric sphere of charge density rho, You can even rearrange this formula like this. How? Just one second. Yes. Now, electric field inside x divided by 4 pi epsilon 0 r cube. Now, q is left. Q is nothing but rho times 4 by 3 pi r cube. Rho times 4 by 3 pi r cube is the, yes, now you get. So, this is standard rule. Electric field inside a non-conducting sphere is given by rho times x divided by 3 epsilon naught. It is one of the standard relation you may remember if you are preparing for NEET or IIT JEE, right? You may remember this. Please check that. But anyway, second round I will come for IIT JEE, complete all the important formulae, I will come. Check it. Now, what is electric dipole and its potential? So, dipole suppose plus q minus q. What is potential at this point? Theta. What is potential at this point at distance r, point P? What is potential at this point? Potential at this point is given by, come on, P cos theta divided by 4 pi epsilon 0 r square. This is electric potential due to dipole. Potential due to dipole. Due to a dipole. Potential due to a dipole. Electric potential due to dipole. Whether you calculate electric potential due to dipole, point charge, or whatever may be the distribution of charge, whatever may be the case, one rule is always true. What is it? E is equal to minus dV by dx per Ex. Ey is given by minus dV by dy, like Ez. At the same time, potential at any point is given by negative of line integral of electric field dx or dr dot dr r1 to r2. Negative of line integral of electric field always gives you potential. Sir, enna potential is? To be very precise and very clear, I can tell you this. This is V2 minus V1. This is nothing but V2 minus V1 is what is delta V, change in potential. So, final potential by minus initial potential is given by minus E dot dr. This is what class electric potential difference between any two points is defined as negative of line integral of electric field from one point into another point is what is called electric potential. What is potential? Please recall. Potential na enna recall pannunga, work done per unit charge. Appo if anyone is interested in work done, suppose idu appadi work done mathillama inga paru. What is this potential? This is nothing but work done per unit charge. Work done per unit charge. Enakku work done venumappa enna pannalam? Work done by an external agency is given by minus q times integration, come on, r1 to r2, come on, solve pakkalam, E dot dr. Now the question arises, is it work done by the external agency or work done by the electric field? Try to understand. Negative of work done by electric field gives you potential. Potential is always either work done by the external agency or negative of work done by the electric field. Once again, negative of line integral of electric field gives you potential difference. What is potential difference or potential? Potential is either work done by the external agency per unit charge or negative of work done by the electric field per unit charge. Best, let us try to go work done by the external agency. Upon the potential work done per unit charge by an external agency. Adhanal the Q cross multiply pantingna, what you are getting is always work done by the external agency. Suppose you are the third person standing there and pushing a charge, then work done by you from R1 to R2 is simply given by this formula. So this is very important technique. You should be very clear with this. Is there a doubt, please put it on chat box, please. John Richardson said, tell me, Kanna, are you thorough with this? It's a very typical point, very important point. Once again, I'll try to tell you. Potential or potential difference at any point is basically defined as negative of line integral of electric field. Suppose you want to go to gravitation. Gravitational potential difference between any two points is defined as negative of line integral of gravitational field per unit mass. Okay, negative of line integral of electric field, say gravitational field instead of electric field, that's all. Appo na enna solla varena anga potential therinjidhu. Potential enna, what do you mean by potential? Potential is work done by external agency per unit charge. Appo work done by external agency, idhula adikari confusion varum, work done by external agency ya work done by the system appdinu confuse aagakudadu. It is always work done by the external agency. Puriyudha illaya? Yes solunga pakkalam. Come on, tell me yes. Screen sleep mode ku poitudhu. Yes. இன்னும் யாரும் சொல்லியே. Dielectric sphere once again. John wants dielectric sphere to be shown once again. Sure, Kanna? Sure. Yes. Yes, it's a dielectric sphere. Yes. Rajalakshmi, yes, Kanna. Rajalakshmi has joined. Priyanka Revati, Aditya Sharan, Harini. Yes, excellent, Kanna. Excellent. Just keep jotting down. எப்போ நம்ம ரிவிஷன் பண்ணாலும் ஏதாவது ஒரு ரஃப் நோட் எடுத்து வச்சு சும்மா கிறுக்குங்க, ஒரு 20 பக்கம் ஃபில் அப் ஆகிடும். தட்ஸ் ஆல். பி ஹாப்பி. யூ ரிவைஸ் த என்டையர் லெசன். தட்ஸ் வாட் ஐ டூ த்ரூ அவுட் தி இயர். எப்பப்பெல்லாம் நேரம் கிடைக்குதோ அப்போல்லாம் 2 hours கிளாஸ் போட்டு சும்மா ரிவிஷன் பண்ணி விட்டுருவேன். ஸோ தட் நீ வீட்டில் படிக்கலனாலும் குறைஞ்சபட்சம் என் கிளாஸில் உட்காந்து ஆனால் பேனா எடுத்து எழுதணும். சும்மா உட்காந்துட்டு பார்த்துட்டு இருக்கக்கூடாது. பேனா எடுத்து எழுதணும். எழுதுனா யூ வில் கம் அப் இன் ஃபிசிக்ஸ் லைக் எனிதிங். டவுட்டே கிடையாது. ஐ வில் டேக் கேர் ஆஃப் தட். உனக்கு மாதத்துக்கு 2 முறை 1 முறை ரிவிஷன் போட்டு லெசன் ரிவிஷன் பண்ணுறது என்னோட வேலை. ஆனால் நீ வந்து மேலே வரணும். சரியா? குட். எஸ், பொட்டென்ஷியல் கூட முடிச்சிட்டோம். அடுத்தது பார்த்திங்கன்னா என்ன பண்ணோம்? பிஹேவியர் ஆஃப் கண்டக்டர் அண்ட் பிஹேவியர் ஆஃப் நான் கண்டக்டர் இன் எக்ஸ்டர்னல் எலக்ட்ரிக் ஃபீல்டு. ஆல்மோஸ்ட் டைரெக்டாக கெப்பாசிட்டருக்கு வந்துட்டோம். நம்ம almost we have come to capacitor directly. Shall we go for next? Yes, capacitor. What do you mean by capacitor? Capacitor is a device used to store large quantity of charge in very small space. Large quantity of charge in very small space by using the technique of induction. Just like a capacitor is a device used to store large charge on a small space or small area, small space better, right? Come on, Kanna. Under this, the first heading is, what is charge on the given body? Suppose the body has got charge. Come on, the body has got charge. Obviously, when the charge increases, its potential also increases. So charge is directly proportional to potential. So charge is directly proportional to potential. So Q is equal to C into V, where C is a constant called capacity of the given conductor or a body or capacitor, whatever you call. Yes, suppose in my case now here I have taken some irregular body. Let us call it as body. So the capacity of the body is given by Q by V. So if you have a sphere, suppose by chance, then what is capacity? Simply capacity is given by, right, charge by, what's its potential? Potential of a sphere on the surface is given by Q divided by 4 pi epsilon 0 R, where R is the radius of the sphere, suppose R, where R is the radius of the sphere. Yes. Then you can find that capacity of a sphere is given by 4 pi epsilon 0 R. Capacity of a sphere is given by 4 pi epsilon 0 R. Very frequently we use in CBSE as well as IIT. Capacity of the given sphere is simply given by 4 pi epsilon 0 R, right? Now, our important point, parallel plate capacitor. Parallel plate capacitor. 2 parallel plates, each of area A. The distance between them is D. One is positively charged, another one is negatively charged. Electric field E is given by sigma by epsilon naught. Sigma is given by charge by area. This is the parallel plate capacitor and its electric field and all those things. Yes, let us begin now. What's the capacity of a parallel plate capacitor is given by epsilon 0 A by D. If dielectric field C dash is given by epsilon 0 A divided by D minus T plus T by epsilon R. It's a metal filled is dielectric field C double dash epsilon 0 A divided by D minus T, because epsilon R is infinity for metal, it will disappear. This will disappear in the case of metals. Then comes, if a capacitor is fully filled, 100% filled with dielectric, 100% filled with dielectric. Say this case, you fill 100% means D is equal to T, this equation becomes, this is vanishing, then T becomes D, then this epsilon R goes numerator. Therefore, your new capacity is given by, epsilon R times epsilon 0 A by D, which is nothing but epsilon R times C naught, is what is called C, capacity of a completely filled capacitor, I mean fully filled dielectric. Can you think of fully filling with metal? No such idea, because if you fill fully with metal, look at here, D is equal to T. If you substitute in the case of metal, your capacity will become infinity, means you keep on giving charge, the entire charge keep on going to earth. There is no meaning in that. You don't have any measurement of capacity becomes infinity. If you fill the capacity fully with metal, 100% with metal, okay, therefore you can fill with dielectric, thereby you are increasing your capacity epsilon R times, you are increasing the capacity epsilon R times. Clear? Come on, tell me, shall I move on with the parallel plate capacitor to next? Shall I move on to next? Shall I go for energy stored series parallel combination? Please put me on chat box. Priyanka Revati, come on, Rajalashmi, come on, tell me Kanna. Shall we go ahead? Sharing of charge and all those things. Sharing of energy, sharing of charge, all those things. Shall I go ahead? In the case of parallel plate capacitor, please use chat box to respond me, please. Aditya Saran, yes. Yes. Harini, yes. Okay. Aditya Saran, okay. Amrita, okay. Priyanka Revati, yes. Everyone is telling yes. Okay, fine. So I can easily move. Okay, fine. Now go to next. Sorry, add page. So now I have parallel plate capacitor. Its capacity is given by epsilon 0 A by D, and I connect it to a potential V. Potential V is being now applied. Thereby, it's getting positively charged, it's getting negatively charged. Thereby, I get electric field given by potential gradient. Perfect. No, sigma by epsilon naught. Perfect. This is also perfect. What is sigma? Q by A epsilon naught. Everything correct. All are correct. Whatever you want, the way you want, you can use it. Fine. So this is a capacity as well as electric field. Potential also decided. Now this is the direction of electric field. This is the direction of electric field. Good. Next என்ன பண்ண போறோம்? Next என்ன செய்ய போறோம் சொல்ல பார்க்கலாம். Energy stored. Come on. Energy stored in a parallel plate capacitor. Energy stored is simply given by half C V square Q square by 2C half into Q into V. These are the various formulae for energy stored in a parallel plate capacitor or any capacitor, not only parallel. Right. Now, what is energy density? What is energy density is simply given by energy by volume. Energy by volume. Energy evlakku of CV square, volume D into A. So, you know the standard for result of epsilon 0 E square. This is the energy density of electric field provided the electric field is uniform. That is very important. Provided the electric field is uniform. Yenna neenga E square use pandringa. So, this formula you cannot put anywhere in electrostatics. This can be used wherever the electric field is uniform. Say for example, here the electric field is uniform. Look at this is an uniform electric field. This is an uniform electric field. Uniform electric field. Yes, you can use it here. This use pannalam, right? But suppose the electric field is not uniform. For example, there is a point charge Q. Electric field. Now you look at this electric field is not uniform. This electric field is not uniform. Now you cannot afford to use this. Use panna mudiyadhu. You cannot use it. You have to integrate for energy density. Adhanal in the formula can be used. This formula, this particular formula of epsilon 0 E square can be used only in the case of uniform electric field wherever you have. Okay. Non-uniform na enna pannum, the integration dhaan ponnum, vera chance kedhu. There is no other go. Clear now? Check it. Rishabh, good. Rishabh well responded. Sriram alaya kaanu engo, Sriram enga poyachi. Satvika has been responding. Very good, Arun. Yes. Very good, Kanam. Come on. Capacitors series parallel pathallama. Capacitors series parallel poillama. Shall we go for capacitors series parallel? Series and parallel combination of capacitors. Series parallel. Potential V, C1, C2, this is V1, this is V2, potential difference. We are sure V is equal to V1 plus V2, we are sure because it is series combination. But one thing, because it is series combination, Q1 equal to Q2 is equal to Q. There is nothing called Q1, Q2, all the charges must be equal. Upper plus minus, all the charges are equal. Come to parallel combination. In the case of parallel combination, this is the first capacitor, the second capacitor, and a battery is connected. Plus minus, potential is V. Right. Now, V1 equal to V2 is equal to V because it is a parallel combination. But Q1 is not equal to Q2. Think of what is not equal. V1 is not equal to V2. May not be equal to V2. May not be equal to, may not be equal. Okay. But suppose it is C1, it draws its own charge Q1. This is C2, it draws its own charge Q2. Because Q1 plus Q2, the total charge here is Q. Total charge here is Q, given by Q1 plus Q2. Upon Q is equal to Q1 plus Q2, we are sure. Sir, very simple. I want to calculate V1 and V2 by shortcut method. That shortcut method, the V1, V2, that's what is our idea now. Right? We want to know V1, V2. Come on. In this case, V1 is given by C2 times C1 plus C2 V. V2 is given by C1 times V C1 plus C2. The potential on 1 depends proportional to C2. Potential of 1 is proportional to C2. When potential, anyone having less capacity will draw more potential, anyone having more capacity will draw less potential. In simple language, potential of 1 is decided by C2, potential of 2 is decided by C1, right, C1 by C2. I think you can understand this. Come to the other side, in parallel combination, Q1, who is going to decide Q1? Q1 will be decided by C1 itself. If C1 is having more capacity, he will draw more charge. If C1 is having less capacity, he will draw less charge. Appo enna avuduna C1 by C1 plus C2 times V, right, not V, Q is the total charge, Then see, this is the total potential, I am dividing for V1 and V2. Total potential is divided for V1 and V2. Here the total charge is divided between Q1 and Q2. Come on, Q2 is equal to C2 divided by C1 plus C2 times the total charge. The concept yes solunga. This will be useful even in CBSE, not only for IIT. This IIT is a very preliminary case, but in CBSE also we can use this technique many times in our problems. Come on, concept purida. Here in parallel combination, each capacitor draws charge based on their own capacity. More the capacity, more the charge they take. Therefore, Q1 is directly proportional to C1. Whereas in series combination, if a given capacitor, series combination 2 capacitor, if one capacitor has got more capacity, he will drop only less voltage. So the voltage depends on the other thing. The potential of 1 is being decided by the capacity of 2, not by the capacity of 1. You are getting it? Come on, yes, Kana. Arun said yes, Arun Kumar said yes, Satvika said yes, Aditya, Sriram, yes, yes, Satvika again, yes. Excellent, Kana. Excellent. I think now I can go ahead with it. I think next I have to take you for sharing of charge and all the shortcut techniques. Sharing of charge. Let me go to sharing of charge. Again, CBSE மட்டும் தான் முடியும் போல இருக்கே போற போக்க பார்த்தா nearly 1 hour gone now. பார்க்கலாம் முடிஞ்ச வரைக்கும் பண்ணிடுவோம். Add. So now I have to take you for sharing of charge. Sharing of charge. Sharing of charge. So if the first capacitor C1 is charged to the potential V1, means Q1 equal to C1 V1. The second capacitor C2 charged to the potential V2 means Q2 is equal to C2 V2. Now these two capacitors are connected in, these two are connected in parallel, so that they can share the charge, Once they share the charge, you get something called V common, C1 V1, C2 V2, C1 plus C2, means Q1 plus Q2 by C1 plus C2, means Q total by C total. This is the basic idea of V common. So when two capacitors, one capacitor is separately charged, say 50 volt, another capacitor is separately charged, say 100 volt, now you join them. There is no guarantee because it's a 50, it's 100, so the answer is 75. No, all those depends on what's the capacity of first one, C1 and C2. But however, because you are connecting in this case, you are connecting the capacitors like this. For example, I show you. Suppose you are connecting them like this. Already this was positive plate. Already this was positive plate. You are connecting them. Already this was negative plate. Already this was negative plate. You are connecting them. Apo, there is no loss of charge. The total charge is alive. It was Q1, it was Q2. So there is no question of adding of charge or subtracting of charge or leaving of charge, movement of charge. This is there. Therefore, the technique is total charge by total capacity gives you the potential, common potential. அப்போ இந்த கேஸில் என்ன நடந்திருக்கும்னா, when you one capacitor and another capacitor, when you join them like this, plus plus and minus minus, when you join, that's what we say connected in parallel. Plus plus and minus minus together join, it's called parallel. When you join like that, what happens is exactly charge flows from one capacitor into another capacitor. Which capacitor to which capacitor? Not higher to lower, not more charge to less charge. It goes from higher potential to lower potential till all of them attain equal potential. I mean both the capacitors, only 2 I have taken instead. You can have 3, you can 4 also. Okay. So to both the capacitors attain equal potential. Once they attain equal potential, the movement of charge stops. Therefore, it is wrong to say that the charge flows from higher quantity of charge to lower quantity of charge. Wrong answer. Higher capacity to lower capacity, wrong. It flows from higher potential to lower potential irrespective of charge there. புரியுதா? ஒரு சில சமயத்தில் சார்ஜ் குறைவாக இருக்கலாம், பொட்டன்ஷியல் அதிகமாக இருக்கலாம். அப்போது இந்த கேஸில் என்ன நடக்குதுன்னா, the charge moves from lower charge to higher charge, the immaterial. The question is higher potential to lower potential it moves. புரியுதா நான் சொல்கிறது? Is it clear? So finally it attains common potential. Then if now this Q1 is no more, this Q2 is no more, now Q1 dash, final charge, final, is given by C1 V common. Then Q2 dash final is given by C2 V common, right? C2 V common. So C1 V common, C2 V common are the final charges. What about energy? What about energy in this case? In these cases, what about energy? Energy என்ன இருக்கும்? Energy initial எவ்வளவு இருந்திருக்கும்? What would have been the initial energy? E1. What would have been initial energy? Come on. What would have been initial energy? Come on. E1 is given by of C1 V1 square. E2 of C2 V2 square. These are the initial. What about the final? Of C1 plus C2 V common square. This would have been energy final. So one can easily prove that total initial energy is more, the total final energy is less. There is definitely loss, LOSS, loss of energy. What's the formula for energy loss? Energy loss, loss of energy, sorry, loss of energy loss, right? Delta E is equal to of C1 C2 C1 plus C2 into V1 minus V2 the whole square. In simple language, C1 C2 divided C1 C2 the effective capacitance in series given, and V1 minus V2 the whole square. However difference the potential, so much of there is a loss of energy. Therefore V1 minus V2 the whole square. This is energy loss while sharing. What is this? Loss of energy in sharing charges. Loss of energy in sharing charges. Loss of energy in sharing charges is given by of C1 C2 divided by C1 plus C2 into V1 minus V2 the whole square is loss of energy in sharing the charge. Please check it. Shall we go to next part? Tell me yes on chat box, please. Please tell me yes on the chat box so that I can go ahead. Rajalashmi gave me permission. She says yes. Others, come on, respond me. Others, please. Yes, my dear kids. You feel bored of revision? So I thought I should give some revision after a long gap. I think we had a gap. Amrita, yes. We can go ahead, can I? Sure. Can go ahead. Priyanka Revati, okay. Aditya Sriram, yes. அடுத்து என்ன பார்க்கணும், எனர்ஜி லாஸ் வரைக்கும் பார்த்துட்டோம் இல்லையா. we have seen up to energy loss. yes கண்ணா, எனர்ஜி லாஸ் பார்த்துட்டோம். அடுத்து என்ன பார்க்க போகிறோம் சொல்லுங்களா, sharing of charge between the spheres. sharing of charge between spheres. sharing of charge between spheres. sharing of charge between spheres. Now I give some charge to the sphere, it takes, but it is connected by wire, therefore it is transferring charges to this. How long it is transferring? See, I am giving charge only to this fellow, but this fellow transfers to the other fellow also because they are connected by wire, How long this fellow will transfer the charge to the other fellow? Let the total charge on this fellow is Q, total charge on this fellow is Q, then the charge may flow from small to big or big to small until both of them attain equal potential. Now what is potential here? Q divided by 4 pi epsilon 0 R. What is potential here? Q divided by 4 pi epsilon 0 R. So clearly, come on, chal bakla, Q by Q, R by R. Q by Q is equal to R by R. Got it? So simple language, charge is proportional to radius. Charge is proportional to radius. So Q1 by Q2 is equal to R1 by R2. இப்படி கூட கேட்கலாம் ஒரு கொஸ்டின்ல, இப்படி கூட கேட்டிருக்காங்க many times in the entrance. Any doubt on this please? இப்போ நான் டிஸ்கிரைப் பண்ணியிருக்கல போர்டில், இட்ஸ் ஆக்சுவலி இட்ஸ் பிட் நியூ கான்செப்ட். நம்ம சிபிஎஸ்சியில் இந்த அளவுக்கு நடத்தியிருக்க மாட்டோம், பட் இட்ஸ் வெரி சிம்பிள் கான்செப்ட். யூ அண்டர்ஸ்டாண்ட் திஸ்? கம் ஆன், டெல் மீ எஸ். யூ அண்டர்ஸ்டாண்ட் திஸ்? ப்ளீஸ் டெல் மீ எஸ். கம் ஆன் கண்ணா ப்ளீஸ். நவ் ஐ வாண்ட் டு நோ ஃப்ரம் யூ வெதர் ஐ மிஸ்ட் எனி டாபிக் இன் சிபிஎஸ்சி பாயிண்ட் ஆஃப் வியூ. ஏதாவது டாபிக் மிஸ் பண்ணி தான் டாபிக் மட்டும் ஜஸ்ட் டெல் மீ த டாபிக், ஐ கேன் பிக் அப் ஃப்ரம் தேர் அண்ட் ஐ கேன் கோ ஹெட். ஸ்ரீராம், கேன் யூ டெல் மீ? ஆதித்யா, கேன் யூ டெல் மீ ப்ளீஸ்? நம்ம ஏதாவது டாபிக் மிஸ் பண்ணியிருந்தா சொல்லுக்கண்ணே, அதை அப்படியே எடுத்துடலாம். கமான். ஏதாவது டாபிக் நான் மிஸ் பண்ணிட்டேனா ப்ளீஸ் செக் யுவர் நோட் புக், யுவர் டெக்ஸ்ட் புக், யுவர் ஸ்கூல் நோட்ஸ் எல்லாத்தையும் செக் பண்ணி சும்மா அந்த டாபிக் மட்டும் சொன்னீங்கன்னா போதும். எனிதிங் தட் ஐ மிஸ்ட், ஸோ தட் ஐ கேன் மேக் யூஸ் ஆஃப் த ரெஸ்ட் ஆஃப் த டைம் ஐ கேன் கம்ப்ளீட். அதர்வைஸ் ஐ ஹேவ் டு கோ டு ஐஐடி லெவல். நோ ப்ராப்ளம், ஐஐடி லெவலும் போயிடலாம். உங்களுக்கு என்ன டாபிக் இல்லை, உங்களுக்கு எதனா ரீடீச் பண்ணணுன்னா கூட எனி டாபிக் யூ டெல் மீ. கம் ஆன், ஜஸ்ட் டெல் மீ த டாபிக். No doubt, very good. No doubt. Satvika, no doubt. Aditya Sriram, no doubt. வேறு யாருக்குண்ணே டவுட் என்ன சொல்லுங்கள். நான் சிபிஎஸ்சி லெவலில் தான் இன்றைக்கி நடத்தியிருக்கேன். ஐ ஹவ் நாட் என்டர்ட் இன் டு ஐஐடி அட் ஆல். சும்மா இங்கே ஹியர் அண்ட் தேர் லேசாக சொன்னேனே தவிர ஐ நெவர் டச் ஐஐடி. ஏன்னா இட்ஸ் ஜென்ரல் ஸ்டூடெண்ட்ஸ், so I don't want to bore you by teaching IIT, but IIT I will definitely do separately. I will put one class. Probably we can go for another class and we can do that. Come on. ஏதாவது டாபிக் மிஸ் பண்ணியிருந்தால் சொல்லாமே. சார் இது விட்டுட்டீங்க, பொட்டென்ஷியல் டியூ டு திஸ், ஏதாவது சொல்லாமே. யூ கேன் டெல் மீ சம்திங். ஏன்னா எனக்கு எதுவுமே நான் டிரைவ் பண்ணல, எல்லாமே டேக் இட் கிராண்டட் தான். இது ஒரு சின்ன கான்செப்ட் தான் டிரைவ் பண்ணிட்டுருக்கேன். கமான் கண்ணே, நோ டவுட், நத்திங் இஸ் லெஃப்ட். குட். ஸோ இதில் இப்போ சிக்மா போயிடலாமா? கமான். Now this charge can be written in terms of, look at this, this may be written in terms of sigma. இப்போ இது வந்து நம்ம sigma 1, sigma 2 அந்த மாதிரி வச்சுக்கலாம், ரைட்டா? ஸோ திஸ் இஸ் என்ன பண்ணலாம், இது capital Q, I want label it as 1, I want label it as 2, right? So இங்கே what is charge on this? Charge capital Q is given by sigma 2 into 4 pi r square, because it is sigma 2. This is sigma 1, right? Similarly, what is small q? Sigma 1 multiplied with 4 pi small r square. is equal to R by R, is equal to R by R. Yes, இப்போ சொல்லுங்க பார்க்கலாம். R cross multiply sigma 2 by sigma 1 is equal to small r by capital R. So clearly it is inversely proportional. Look at it is inversely proportional. Look at, therefore here you can write that sigma 1 by sigma 2 is equal to R2 by R1, R2 by R1. You may recall in the very beginning of the class I told you electric field near any charged conductor, any charge whatsoever the shape, electric field near any charged conductor is simply given by sigma by epsilon naught. If you use this here, you will get that, come on, even by E2, because it is proportional to sigma, E is proportional to sigma. Now simply R2 by R1. புரியுதா? இது 1 2 3 இதை பேஸ் பண்ணி அடிக்கடி சிபிஎஸ்சியில் கொஷின் கேட்பாங்க, செக் பண்ணிக்கோங்க. எனி டவுட் யூ கேன் ஆஸ்க் மீ, டவுட் இருந்தால் சொல்லுங்கள். If you have doubt you can tell me. This is not IIT stuff. Frequently they do ask question in CBSE itself because it is such a simple concept. Look at, ஏதாவது டவுட் இருந்தால் நீங்கள் சொல்லலாம். Yes, yes. Equation number 1, equation number 2, equation number 3. Come on, come on. பாருங்க. Is it okay? So I don't miss I do not miss any topic. Clear? Jairam, no message. Jairam, why don't you give some message? Come on, my dear kids. Come on, my dear kids. So I have a lot of stuff to discuss. Today the message gone very easy flow because it's simply CBSE level, very superficial, very ordinary level, therefore everything gone well. So I will definitely call you for another class during your free time where I will spend at least 2 hours. I will go to higher level. You know, when I move to higher level I may need more time to make you understand, but those classes will not be YouTube, that will be Pakka Zoom or Google Meet, Pakka, okay? So we'll do that, clear Kanna? So IIT level I will call you for another 2 hours class and I will give you all the formulae related to IIT and NEET particularly, clear now? I think it's right time we can wind up for today's class. I think it's enough. Can you put bye on the chat box? Priyanka Revati, sir, could you please explain again the second part? Which second part Kanna? I don't get. This second part you mean? This one, huh? I think this is what she is asking. I remember. I think so. Second part, right? So this is Q2. I call it as Q. This is Q1. I call it as small q. Purida? This is capital Q. This is small q. What is charge? Surface charge density area. Surface charge density area. After cancelling, cross multiply. So you will find that sigma 2 by sigma 1 is small r by capital R. Means inversely proportional to their own radius. Capital charge, I mean capital Q depends on R2, capital R, right? So that becomes inversely proportional. So I universalize the equation. Sigma 1 by sigma 2 is given by R2 by R1. Clear Kanna? Priyanka Revati, come on, come on. Priyanka Revati, come on. Yes. Others may please tell me, shall we wind up the class? So, this class is not meant to teach you anything new, absolutely no. After a bit long gap, maybe 6-7 days, I did not meet you, just because after summer, just I want to have some brush up, I mean warm up rather, instead of brush up, yes, warm up. Therefore, just we started and I could give all the formulae related to CBSE level. Definitely I will meet you with IIT level next class, right Kanna? Can you tell me yes? Shall we wind up? Shall we wind up, my dear kids? Please, everyone should put on chat box, please. Yes, everyone, please. Come on. Arun Kumar has already put. Rajalashmi, yes. Bye. Come on. Thank you. Aditya Sriram, very good, very good. Anyone else? Come on, come on. Satvika, thank you. Satvika M, yes, yes. Rajalashmi, yes. Bye Kannam. Shall we put bye? Yes, yes. We shall meet as per our regular schedule, all the batches. Whatever are your batches, accordingly we will meet Kanna, or accordingly we will meet. Right Kanna? Praneeth Krishna, good, thank you, good, good, good. Priyanka Revati, Shreya, okay, very good, very good, very good Kanna, very good. Aditya Sriram, thank you, bye. Bye Kanna, bye, bye. All of you bye, all of you bye, bye Kannam, all of you bye. Bye, I am closing, bye.